Welcome to another episode of Terry's Notes, and today we are going to be looking at salts. Okay, a salt is a compound formed when some or all of the hydrogen ions in an acid is replaced by a metal or ammonium ion. You need to know this definition for a salt. There are different types of salts. First type is an acid salt. An acid salt is a salt formed when only some of the H+ ions from an acid are replaced. An acid salt can be produced from a dibasic or a tribasic acid. A normal salt is a salt formed when all of the H+ ions from the acid are replaced. The type of salt formed when using a dibasic or a tribasic acid depends on the amount of acid used. Okay? So, for example, an example of an acid salt. Now, remember we said we have to use a dibasic acid or a tribasic acid. Sulfuric acid is a dibasic acid. And if we react it with a base like sodium hydroxide, we get, an alkali like sodium hydroxide, we can get NaHSO4 plus water. Now, in this case, we have only replaced one of the hydrogen ions from the acid, right? And we end up with sodium hydrogen sulfate, which is the acid salt. If we have a different scenario taking place where we replace all the H+ ions. Now, when we are speaking about the H+ ions, we have two H+ ions present here. And if we replace all of them with sodium ions, we end up with Na2SO4 plus water. And the NO2SO4 is a normal salt, right? Solubility of salts. Now, you need to remember these things. All nitrates are soluble in water, right? All sodium, potassium, and ammonium salts are also soluble in water. All sulfates are soluble in water except lead sulfate, barium sulfate, mercury sulfate, and calcium sulfate. All chlorides are soluble in water except silver chloride, lead chloride. Lead chloride is soluble in hot water. And all carbonates are insoluble except potassium carbonate, sodium carbonate, and ammonium carbonate, which makes sense because we just said that all sodium, potassium, and ammonium salts are soluble in water. All metal oxides are insoluble except potassium oxide, sodium oxide, and calcium oxide. And all metal hydroxides are insoluble except potassium hydroxide, sodium hydroxide, and ammonium hydroxide. So you need to take some time and remember this page because you need to know how to determine which salts are soluble or not, because that is important in terms of describing how we prepare a salt. So let's start with the easiest one. How do we prepare an insoluble salt? Insoluble salts are prepared by precipitation. So we know that lead 2 chloride is insoluble. So if we want to produce lead 2 chloride, we need two soluble salts. In this case, we are using lead nitrate because all nitrates are soluble, and we are using potassium chloride because all potassium salts are soluble. And what we produce is lead 2 chloride and potassium nitrate. So this is the salt we are trying to produce, and we are using two soluble salts to make it. So the procedure is we add aqueous lead 2 nitrate to aqueous potassium chloride, and what we will get is a precipitate. So we filter to remove the precipitate formed, we wash the precipitate with distilled water, and we dry the precipitated salt with filter paper. Now, this is a typical examination question, and you have to be able to state the steps as to how to prepare the salt. Now, if we want to prepare a soluble sodium, potassium, or ammonium salt, what we have to do is do it via a titration method, right? So the salt is prepared by reacting an acid with an alkali. So if we want to produce sodium chloride, we need something like sodium hydroxide and hydrochloric acid, in which case we will produce sodium chloride and water. So first thing we do is we pipette 25 cm cube of a 1 mole per dm cube sodium hydroxide into a conical flask. We add 2 to 3 drops of phenolphthalein indicator, and we slowly add the hydrochloric acid from a burette into the conical flask while shaking. Then we note the volume of the hydrochloric acid required to neutralize the sodium hydroxide by observing the color change in the indicator at the endpoint. And then what we do, because we recorded the volume, we repeat the titration, but this time we don't use any indicator, but we're using the same volume of acid we determined before. And what we do, we heat the solution just to evaporate some of the water, and we leave to crystallize. Okay. Okay. In this case, once we leave to crystallize, we'll have a dry sample of the salt. We could rinse it with distilled water and dry it between filter paper. In this next salt preparation, we want to prepare soluble salts of either sodium, potassium, or ammonium salts. Hold on one sec. Right, so in this case we are preparing soluble salts other than sodium, potassium, and ammonium salts. Right, these salts can be prepared by reacting acids with metals, insoluble bases, or insoluble carbonates. So for our example, we are trying to prepare calcium nitrate. So what we do, we use calcium carbonate, which is insoluble, and we react it with nitric acid, and we get calcium nitrate, water, and carbon dioxide. So the steps we need to remember: we add excess calcium carbonate to the nitric acid until effervescence stops, meaning that we are reacting all the nitric acid. Then we filter to remove the excess calcium carbonate, and we collect the filtrate. The filtrate is evaporated until the solution is saturated. The saturated solution is allowed to cool so that crystallization takes place. We wash the calcium nitrate crystals with distilled water, and we dry with filter paper. Now you see these steps here, they are very important. Typical examination questions, and you have to be able to describe the steps. If we wanted to prepare an anhydrous binary salt, for example iron trichloride, the two elements are heated together. So in this case we have a piece of iron wire, and we have chlorine gas entering this tube, and as we heat, the iron reacts with the chlorine to produce iron trichloride. Now we need to understand what is water of crystallization. Salts tend to have a fixed amount of water in their crystal lattice, and this is called water of crystallization. This water affects the shape and color of crystals. A salt can be heated in order to remove the water of crystallization. So hydrated copper 2 sulfate is blue, but heating it produces anhydrous copper 2 sulfate, which is white. So it is because of the water molecules present in the salt that the copper 2 sulfate is blue. Right? So hydrated copper 2 sulfate can be written as CuSO4 dot 5H2O. Right? That is how we write water of crystallization. And when we heat it, we eventually get copper sulfate, and the water is removed, and the copper sulfate is white. So white anhydrous copper 2 sulfate can be used as a test for the presence of water. It changes from white to blue. Okay, we need to understand some dangers of using salts. Okay, uses and the dangers of using salts. Now, calcium carbonate is used in the manufacture of cement. Alright. Sodium chloride, sodium nitrite, sodium nitrate, and sodium... there's a mistake here. Is used in fruit preservation. So we tend to use a lot of nitrates and nitrites in meat preservation. Calcium sulfate is used in plaster of Paris when people break their arm and they go to get a cast. The cast is really made up of the salt calcium sulfate, and magnesium sulfate is used as Epsom salts. All right. Sodium nitrate. There's some research showing that there could be possible brain damage in infants, and is also suspected to be a carcinogen, meaning that it can cause cancer. Right. And the last thing we need to look at is the farmer's dilemma. Now, farmers use fertilizers to help their crops grow. Nitrogen is required in plant to produce plant protein. All right. Now, ammonium sulfate and ammonium nitrate are fertilizers, and they are slightly acidic. So, the farmers, they want to use fertilizers to help their crops grow, and they add, but because the ammonium sulfate and the ammonium nitrate is acidic, they tend to add lime, which is calcium oxide, to neutralize the acidity. The lime, which is calcium oxide, reacts with water to form calcium hydroxide. So CaO plus H2O produces calcium hydroxide. The calcium hydroxide reacts with the fertilizer to produce ammonia gas. Right? Because remember, we just said that the fertilizers are acidic. So 2NH4Cl plus CaOH taken twice produces 2NH3 plus CaCl2 plus 2H2O. This equation should look familiar to you because this is how we typically prepare ammonia gas. So the ammonia gas produced escapes into the atmosphere. So therefore we have less nitrogen now available for the plants to make plant protein.